Welcome to Lecture 9 on the Newtonian Revolution. The Newtonian Revolution because Newton's Principia mark not only a major event in the history of Western science, but mark the initiation of a revolution in Western culture. It is not merely a scientific event, it is a cultural phenomenon as well. As natural philosophy, the simplest way to understand Newton's Principia is that it was a mathematical demonstration of the Copernican hypothesis that the sun, not the earth, was at the center of the solar system as proposed by Keplar. Copernicanism consistent with Kepler's 3 laws of planetary motion. No one had demonstrated that hypothesis or Kepler's posing of that hypothesis. Newton's Principia provide the mathematical proof of the hypothesis in the minds of Newton's contemporaries. Let's note several obvious things about the Principia, for one doesn't want to miss the forest for individual trees. One, it is a profoundly empirical work. It, both in its practice and in the theory of knowledge that Newton propounds in its pages. It tells us that we learn about nature from the empirical study of nature, that we are to proceed inductively, framing generalizations that are tentative claims of knowledge, whose force lies in their confirmation by experiment and further observation, and that are always subject to correction, to emendation by later knowledge and by later experiment. They are, Newton tells us, to be held as true only for so long as inductive evidence continues to support them. 2, Newton's Principia are mechanistic. That is to say, the goal of the Principia, the model of knowledge, the explanation of phenomena that works, that holds the Principia together, that there are laws of mechanics governing the behavior of matter in motion. In that sense, Newton's Principia are the ultimate overthrow of scholastic physics. The goal of scholastic physics in the context of scholastic metaphysics, of that essentialistic and teleological worldview of which we have spoken, is to understand, above all, with ever greater particularity, how the motion and behavior of every particular moving entity, behaving or acting entity in the world expresses its particular nature, its particular perfections and essence, its particular purposes. The goal of Newton's physics is to have the most general law supported by data and experiment and demonstration. The most general law that explains not every particular act and behavior by the properties and purposes of particular entities, but that seeks explanation in terms of matter in general, of mass in general, and in terms not of the purposeful motions of any particular object, but of laws of motion in general. So in these foundations, in notions of mathematical order, empiricism, and generality, Newton offers to the world a simple formula that, as he will put it, allows me to explain the system of the world. It is simply that there is a force of gravity by which m times m1 over d2 operates throughout the physical world, meaning that there is a force that varies proportionally to any two masses whatsoever, wherever they are in the universe, and inversely according to the squares of the distances between those two bodies. m1 over d2, d squared, m1 over d squared explained all of the then known phenomena of celestial motions by the supposition of that force of gravitation. That is an astonishing scientific achievement. The mathematics, the observation, the patience behind that formulation is a singular scientific achievement, but it is a cultural phenomenon as well. For that formulation, m1 over d squared makes the world seem ordered and lucid. And it made the human mind seem capable of understanding the very architecture and design of God in nature. Think of it. That law is the wisdom of God made manifest throughout the natural world. Contemporaneous reaction to Isaac Newton's Principia Mathematica immediately let us understand that we are dealing with so much more than a scientific phenomena. Edmund Halley, the celebrated astronomer, penned an ode that was published as a preface to Newton's Principia. It ends with the words, "Nearer to the gods, no mortal may approach." Nearer to the gods, no mortal may approach. When Newton died in the early 18th century, the great English poet Alexander Pope wrote Newton's epitaph, and Newton is buried in Westminster Abbey at the center of English religious and political life. His epitaph, as penned by Alexander Pope: "Nature and nature's laws lay hid in night. God said, 'Let Newton be,' and all was light." Nature and nature's laws lay hid in night. God said, "Let Newton be," and all was light. In the 1730s, the great French Enlightenment philosopher Voltaire, writing his letters from England to the French nation and explaining to them what Newton had done and why they should prefer Newton, though English, to Descartes, though French, in physics, wrote, "Descartes put us on the road to truth. Newton took us to the end of that journey." In the early 19th century, Napoleon called the greatest astronomer in France to his court and said, "Will there ever be another Newton?" The reply, "Sire, there can be only one Newton because there was only one universe to discover." If one thinks about those reactions to Newton, one understands with great force that this is not simply a work of science, of physics, of astronomy, that it changes the human species sense of how you know the world, of what you can know about the world, about whether that world is incomprehensible and we are doomed to fatalistic ignorance about its structure, or whether we may understand with comprehension the universe in which we find ourselves. It changes the culture sense of the powers of the human mind and of the lucidity of God's creation. Isaac Newton could not have achieved what he achieved alone. He was dependent upon the astronomical observations of Tycho Brahe and so many. He was dependent upon the dynamics and mechanics of Galileo. He was dependent upon Descartes' mathematical formulations, and indeed upon the notion of linear rather than natural circular inertia, of linear inertia that he took from Descartes. But his synthesis, that we could specify a force of gravity that acted as the centripetal force consistent with the law governing falling bodies, that pulled the heavenly bodies into the orbits that Kepler had described, is one of the most extraordinary scientific syntheses of the history of the human mind. Now, there is a paradox in the enthusiastic reception of Newton. Almost no one could understand him. The mathematics were so complex. No one knew the calculus, and following Newton's arguments in terms that were not derived from the calculus, that was a business beyond almost anyone's mind. But the popularizers who did understand Newton, and the writers of prefaces to Newton's work, increasingly made it clear to Europe that Newton, through a method of induction and mathematics, had derived the force that acted as the centripetal force, like the chain attached to the pendulum, that explained the planetary system, the heavenly system open to our gaze, and that was wholly consistent with the law of falling bodies and wholly consistent with three laws of motion that accounted for physical phenomena. Think back to the Aristotelian scholastic system, the imperfect earth, mutable, changing, chaotic, the immutable heavens. One of the obvious accomplishments of Newtonian physics for the Western mind is that it linked all terrestrial and celestial phenomena. We did not live in two realities, governed in two different ways, We were not part of two systems created by God. We lived in one physical universe, governed by uniform laws of nature. And those who could not follow Newton's explanations and proofs could follow one thing and understand its implications with full force. The predictions that followed from Newton's Principia held. They were true. On the basis of the Principia, you would predict Kepler's orbits, and those orbits were consistent with all observation. You could predict planetary and celestial motions. You could predict the return of comets, and no small part of what made people fully understand the drama of what Newton had accomplished for the first time in human history. You could predict the tides, because the tides were explicable in terms of the moon's gravity. Newton also produced a very dramatic moment for Western science in the confrontation between Newtonian and Cartesian natural philosophers and physicists. Think about the Cartesian assault upon scholastic physics. For the Cartesians, the world was a mechanism in which matter communicated force to matter by touching it in space, by laws of mechanics and dynamics. The Cartesians thought they had rid Western philosophy of the Aristotelian imputation of secret forces that couldn't be observed, but that acted to express the perfections or qualities of things. Those were known as occult forces. You couldn't see them, but you knew from behavior that they operated. The Cartesians were certain that they had mechanized and rationalized our understanding of the world and rid us forever of the Aristotelian occult forces that seemed to them an anti-science, an anti-reason, an anti-mechanism. If you look at anti-Aristotelians of the 17th century who mock the Aristotelians, anti-Aristotelians who mock them, think of the great French playwright Molière's play, Le Médecin Malgré Lui, the medical doctor in spite of himself. He has to take his doctoral examination, and he is asked, why does opium put someone to sleep? And he answers, because of its dormitive power. And the doctors say, learned, and pass him for his final and highest degree. There are the Cartesians mocking the Aristotelians. Why does opium put one to sleep? Because of its dormitive power. That's no knowledge at all. Let's understand the physiology. What does opium do to the nervous system? How does matter affect matter? Take away occult forces and talk about the communication by matter to matter. Well, how do the Cartesians read Newton? Why do the planets hold their orbits? Because of the power of attraction. Why is the moon an ellipse? Because of its power of attraction. Action at a distance. How could that be? For the Cartesians, there must be solid matter between all the planets and the Earth, and they too are Copernicans. And there must be whirlpools, vortices of matter set into motion by the rotation of the planets, by the rotation of the sun, all of which bring about the solar system. And we must find the mechanisms by which matter directly touches matter and communicates force. And what is Newtonian gravity but an occult force, action at a distance? Initially, Newton wants to know, how does gravity communicate itself? Newton wants to know from what properties of matter is gravity derived. But there are no answers there, and Newton and the Newtonians make a virtue out of necessity and change the nature and scope of Western science forever. It is not our job to explain why nature is as it is. It is not our way to explain even in what ways forces come to be in the world. It is the job of science to explain that a certain force exists, operates, and accounts for phenomena. But what is gravity, Newton is asked? What does it come from? How does it communicate itself? How do things affect each other at a distance? Newton answers, non fingo hypothesis. I do not feign hypotheses. Absent knowledge, I will not make up a hypothesis. I will admit ignorance. I do not know why gravity should be. I do not know how gravity communicates from one body to another. I know that it is a force that exists and operates in nature and accounts for the phenomena. And indeed, Newton and the Newtonians find that many other of their goals are fulfilled in this debate with the Cartesians. If you think back to Descartes' system, in which he derives the law of inertia as a necessity given God's fixed and immutable will, from God as perfect, Descartes deduces God's immutability. From God's immutability, Descartes deduces that he sets matter into motion, that he must set matter into motion according to the fixed laws of mechanics. For the Newtonians, the inexplicability of why forces should be in nature simultaneously recognizes the limits of human knowledge, the need to admit ignorance absent data, but it also underscores God's omnipotence and freedom. One does not, as Descartes did, by metaphysics, deduce what God must have done in the creation. Much as in the Baconian vision, one examines the creation with a recognition of human ignorance and divine omnipotence and sets out to understand what God actually has wrought in the world. Secondly, Newton profoundly believes, and the culture profoundly will believe with him, that his system of philosophy offers proofs of God empirically and inductively from nature, and indeed these proofs will sweep away the appeal of the purely rationalist Cartesian proofs. Newton, interestingly enough, assumes a static universe. We are looking at what was created. We are looking at the solar system as it always has been. And Newton, from the principle of gravity, infers that there ought to be a gravitational collapse of the universe, all matter attracting all matter into a gravitational collapse of almost incalculable density. Why hasn't that occurred, Newton asks. It hasn't occurred because God obviously placed each planet, each star, each bit of matter in the universe, and at exactly those velocities that prevent a gravitational collapse, so that we have absolute proof from nature that we live in a universe designed by supreme wisdom. Cartesian science, to the contrary, says that in order to have an explanation, you must posit a set of laws that show you how we got to the world that we observe. Newton posits the solar system and system of the heavens we observe. Descartes wants a physics without void, without vacuum, matter touching matter everywhere, that will give us the evolution of the system that we observe. Well, Newton has proven powerful in terms of the substantive physics and action at a void. But the Cartesian vision of an ultimate cosmology, an ultimate explanation of how we got from the beginning to the world that we observe, remains a very potent part of the Cartesian legacy in the Western scientific imagination. The most dramatic of Newton's legacies to the culture beyond the science was, of course, the sense that one could see through nature to nature's laws and to the author of those laws, a God who wisely and providentially had designed the world. This meant that nature was lawful and that nature was knowable. It meant not only that God had not intended us to see through a glass darkly, that God had not intended us to wander helpless without knowledge in the world in which we found ourselves, but that indeed all knowledge was a piety. All knowledge was a touching of God. The greatest part of that legacy was the sense bequeathed to Western science and Western culture that there was order and clarity in the physical world in which we found ourselves. Think again on Alexander Pope's couplet and its acceptance by pious England. For it is truly remarkable. Nature and nature's laws lay hid in night. God said, "Let Newton be," and all was light. The great confidence in the method caught up in this achievement made Newton's Principia a paradigmatic work. That is to say, believing in what had been achieved by the method used in this book, believing in the power and the prediction given by the conclusions of this book, one accepts the method that made possible that achievement, so that Newton's Principia gives extraordinary prestige and value to a view of knowledge based upon observation, induction, the mathematization of motion, quantitative, not qualitative knowledge, predictive value, and experiment. It was what Bacon had foreseen about method. God did not intend us for ignorance. We now had a method with which to use our minds, and for many, surely the task now was to extend that method to the whole of human knowledge. Thank you very much.